Hello everyone, finally welcome back to the last session. So, we are going to wrap this up in this session, let us get this started. So, we are looking at stabilization of sludge and we looked at different kinds of stabilization. So, here we have an aerated static pile. As you can see, most of the information is in the name of this particular process itself. It is a static pile that is aerated. So, let us see what it is about. Typically, we are going to stack it right over a porous bed which has air piping. So, porous bed to allow for air or such to be pumped through, and on top of that you are going to stack the material that you want to stabilize, let us say, and you are going to put some finished compost probably as a relevant seed or for nutrients, let us say. And after composting, similar to the different kinds of earlier types of composting we looked at earlier, you can recover some of the bulking agents in screens, right. So, this is what typically it looks like. What do we have? You have a perforated pipe, obviously blower to, it is not continuous, it is only what do we say, requires intermittent what do we say, mixing or air, that is one aspect to keep in mind. You have a porous material and on top of that is what you are trying to stabilize, and then this coating layer typically made of compost, right, and you can see the relevant pictures here. Let us move on. So, evaluation and such, I will only summarize the major aspects without going into detail here. So, we are going to look at flexible changing feed options, let us say, right. It is flexible to changing feed conditions, different kinds of feed conditions, it is relatively more flexible or robust, and as was seen earlier, it requires simple mechanical equipment. But disadvantages, obviously labor intensive, and as you can see it requires a lot of area, let us say, right. You can't have a lot of what do we say, height of this particular or considerable height of the static pile. Why? Mixing is going to be affected. So, large area is going to be an issue and high operator exposure obviously. So, another kind of composting, windrow composting, that is something you would have seen or come across at least in various forums. So, mixture stacked in windrows, meaning long narrow piles, let us say, right, long narrow piles like this. Again, key aspects with composting we discussed earlier: carbon to nitrogen, temperature, moisture content and relevant aeration, right, and mesophilic, thermophilic phase and again mesophilic phase. And you have to turn the windrow, why? To provide oxygen, let us say, right, you have to turn the window, right. This is long narrow piles typically done with front end loader, can have supplemental aeration if this turning itself is not good enough, and then you will have aerated windrows. So, let us move on. So, advantages, again as was the seen in the case of other types of composting, can also here though you can use different bulking agents unlike the one where you had in vessel composting. Again, flexible to changing feed conditions, as can be seen you are just having a pile here, right, and with a front end loader you are just mixing it, right, no fixed equipment required. Disadvantages though, it is labor intensive, large area is required and high exposure operator exposure. Why large area? Because you can't have huge piles out here. Typical piles maybe this height is also pretty high, maybe to my waist, let us say meter and such, depending on how well you are able to aerate it. So, here the issue is with respect to aeration and also moisture control, that is something to keep in mind, right. So, evaluation of composting in general, high quality product which is always a great advantage and which is suitable for agricultural use. It can also be combined with the other process which typically precede it, and obviously low initial cost. But the issue in India though is now because of population density, the land prices are very high, and getting large areas for what do we say, composting of agricultural waste, not agricultural, pardon me, kitchen waste, and for sludge too, I guess, is going to be an issue. So, disadvantages, high solids concentration is required initially, requires bulking agent to promote aeration, requires airflow or turning. Again, all these are tied in. Yes, potential pathogen spread by dust, because if I am what do we say, keeping it open and aerating it, and also you have wind blowing in. So, potential pathogen spread by dust, high operational costs, but this depends upon how well you need to mix it or such. But the key aspect is high land area, and especially in India where the costs are high, at least in the metropolitan areas or cities, that is going to be an issue or a concern. So, if or depending upon the type of sludge, you might need to add carbon source, let us say, right, depending on the type of sludge. And obviously, if you do not maintain it well, you can have odor problems. So, a stopgap stabilization is lime or alkaline stabilization. So, we are trying to add lime. When we add lime, obviously, we typically increase the pH, and then we are going to increase the temperature T at pretty high value for around 30 minutes, right. And if it pH 11.5 up to 22 hours, let us say, right. So, we are going to increase the temperature and the pH, yes. So, pH will drop after initial rise due to reactions such as absorption of carbon dioxide into the material and reaction or into the open atmosphere if it is open system, and reaction of OH with the organics, let us say, right. So, let me move on. So, again as I mentioned earlier, it is good for emergency stabilization, let us say, you are running out of options and your sludge, let us say anaerobic digester has failed or aerobic digester requires maintenance, but you do not want to have pathogens being released or issues with respect to vectors and flies. What are you going to do? I guess you can go for this emergency stabilization, right. So, quicklime storage silo, mixing tank and so on and so forth, and a odor control tank obviously, right. Let me move on. So, evaluation advantages, low capital cost, obviously we are just looking at pH and temperature, which is easy to achieve, but high operational cost probably, and again it is easy operation. And as mentioned earlier, for interim stabilization, temporary stabilization, it is pretty good. Not appropriate for land use, why, or land application later, why? The pH is going to be pretty high depending upon how much calcium is there or such in your relevant lime, that is going to be an issue too, right. And chemical costs have to be taken into account. Overall cost, it depends upon the relevant site, and volume can increase or will increase, I guess, right. pH drop, or if it drops, it can lead to microbial growth and it can lead to odors, let us say. So, conditioning, here we are going to look at what did we do initially. Again we increase the solids concentration, then we are looking at stabilization, where the biodegradable content and mostly pathogens we have taken care of them, and then we have to look at conditioning so that we can go for dewatering later. So, conditioning, we are more or less talking about addition of or improving dewaterability by addition of relevant cation, not exchangers, cations or sometimes polymers, let us say, right. It is similar to what we saw in coagulation and flocculation, relatively similar. But how do I measure that, let us say? So, I can look at specific resistance and try to measure it, right. Here I am trying to look at specific resistance. So, what will I do? I will have a filter paper, and to pump or pull this particular sludge through, I will have a vacuum source, and I will then measure the volume of water that passes through as a function of time, right. So, here is the way to calculate it. Again it is relatively straightforward formula. So, area, pressure drop across that filter of that area, that area of the filter that we looked at, dynamic viscosity, concentration of solids, right. So, you can see the relevant interrelationship out here, let us say, right. So, let us move on. Capillary suction time, again measurement of dewaterability. So, we are going to place the sample in a cylindrical cell on top of a filter, and we are going to measure the time for the wet front to travel 1 centimeters. The time will be capillary suction time. So, as mentioned earlier, we were looking at specific resistance measurement device, and I guess you can see the relevant filter paper here and the relevant sludge or such that you are going to have here, and you will apply vacuum, and you are going to have that what do we say, volumetric cylinder, where you will look at the distance with time, let us say, right, of the wet front with time. So, coagulation, that is what we are talking about here, conditioning. So, typically metal salts like ferric chloride or lime, as we use in the context of water treatment or wastewater treatment, organic polymers to agglomerate small particles, and this is what I think we saw in the IIT Roorkee plant, yes. So, heat treatment is also done sometimes, but this is rarely done. So, relatively high temperatures and at relatively low retention times. So, some organics obviously are going to be oxidized at this high temperature, and that can lead to breaking of the microbial cells. Again dewatering, So, I am done with conditioning, as in preparing the sludge, so that it is now easy to remove or dewater it, right. Again, why am I trying to achieve dewatering? Because if not, the sludge is going to be difficult to handle. So, at the end of it, or the composted or stabilized and dewatered sludge, it should be more like a solid that is easy for me to transport and handle, right. So, that is what I am looking at. Dewatering, plate and filter press, right. I am again, as I mentioned, going to summarize them. We can look at the relevant aspects in detail if required. Let us see. So, what is it that we are trying to do? We are forcing the water from the sludge under high pressure, right. We have a plate and filter here. I am going to push this in, right, and the water is going to come out, let us say, because of this pressure through that particular filter, let us say. And what is this filter press consisting of? Firstly, we have a number of plates that are supported in a common frame. Let us look at the picture and that will be clear. So, during dewatering, these frames are pressed together, right, as I mentioned, and filter cloth is mounted on the surface of each plate, and then the water goes through this, right. So, that is, let me look at the picture. Okay, so, this is what you have. So, these are the different kinds of plates and such, and here you have a filter and the sludge will be here, and then when I press up against it, the water will flow out, let us see, right, through that particular filter. You can look at a relatively good video that explains the mechanism that is given in this link here. Not explains the mechanism, that which will help you visualize the mechanism. So, let us move on. So, design general aspects, obviously pressure is the key aspect and we have to maintain the pressure, right, it is not one stop, and moisture content. So, total cycle time is 2 to 5 hours, let us say, right, depending upon the extent of moisture removal that you want to remove, let us say, or have moisture removal that you want to have. Belt press, this is something similar to what we have seen in the video at the IIT Roorkee sewage treatment plant, right. We saw how sludge was being dewatered. To my knowledge, that was a belt press. Belt filter dewaters by applying pressure to the biosolids, right, to squeeze out the water. But here the key aspect is you are going to have a relatively porous belt. Biosolids which are sandwiched between porous belts are passed over and under. As you saw, there were rollers of various diameters, let us say, right, typically decreasing diameter. An increased pressure is created as the belt passes over rollers which decrease in diameter as we go along, right. So, here we have a belt press, right, a different kind, but the principle is the same as what we saw in the IIT Roorkee sewage treatment plant. So, you have the electrolyte here, chemical conditioning as we mentioned earlier, and we are going to mix it up here, and then you are going to have the conditioned sludge here, right. And initially we are going to have gravity drainage, let us see, where the moisture content is relatively high, it just drains by gravity. As you can see here, it just drains by gravity. The water drains by gravity through this belt, and then we move on to compression dewatering. Compression dewatering, here different mechanisms, one is low pressure section and the other one is high pressure section, let us see. So, you can look at the relevant schematic, but again primary aspect is one is just gravity and the other one is compression dewatering, let us see, and then final product will be sludge cake and wash water or the filtrate, let us see. So, this is a schematic, I guess, and as mentioned we saw the live one in the video earlier. So, let us look at the performance of belt filter press. What is it all about coming to? It is coming to what is the solids concentration here, let us see, right. This is the key aspect. I want to have less water and more solids. What is the solids percentage here? So, let us look at some aspects. One is anaerobically digested, aerobically digested, and let us look at the waste activated sludge, right, and waste activated sludge here, let us see. Okay. So, as you can see, typically it is easier to look at dewatering anaerobically digested sludge than aerobically digested. So, that is one thing that I wanted to point out or mention here, let us see, right. So, I was just trying to look at only WAS. So, if not, I guess we can look at P plus WAS, P is raw primary plus WAS and P plus WAS which is 16. So, you can compare the values out here, let us see, right. So, that is something to keep in mind when we are looking at the kind of stabilization that you want to achieve, not achieve, have, I guess, right. So, hydraulic loading and solids loading and belt width, again these are going to be intertwined, right. So, general design aspects, solids loading, as we saw earlier, the width was also an issue. So, we have kgs per meter per hour. how much am I putting in, how much mass am I putting in per the meter width per time, let us say, right. And hydraulic loading width 1.6 to 6.3 liters per meter per second, right. General values, you do not need to mug them up, but just need to be aware of them. So, after that, here we have an example, aerobically digested solids which have been dewatered with continuous belt filter press. So, this is what I guess typically it looks like, and this is much easier to handle now. So, centrifugation, typical aspect, let us say, we know it is similar to sedimentation device. So, here what are we doing? We are rotating the liquid at high speeds to increase the gravitational force applied on the sludge. So, different kinds, solid bowl and basket centrifuge. So, I will not go into this in detail. So, here we have particular schematic out here, let us see, right. So, let me move on. This is a simple aspect. Again, sludge dewatering centrifuge. Again, even centrifuge too, it depends. For example, belt filter press, the issue is that the loading rate is less, but the energy requirement, the noise issues and such, and also the output is typically better, but for belt filter press. But for centrifuge, more energy is required, okay, and that is always a key aspect, right, but it is not required to be run every time though, or continuously it is not required. Why? Because typically their capacities are higher, but the noise is an issue depending on how well it was what do we say, manufactured, if I may say so. So, these are different aspects to consider. So, again same aspect in the context of cake solids too, same as in the anaerobically digested and aerobically digested waste activated sludge. If you see anaerobically relatively better, what do we say, concentration of the solids, let us say. That is one aspect to always keep in mind when choosing the kind of stabilization. So, another poor man's option is drying beds, right. So, you just have a bed and you are going to look at some particular thickness of the sludge and lay it out there. Obviously, this is when you have less sludge. When will you have less sludge? In smaller plants and which have access to area too, let us see, right. So, small plants, what is it that we do? 20 to 30 centimeters stabilize liquid sludge on the drying bed surface and add chemical conditioners. In India, they do not do that a lot, okay. And what is it that we have? The concentrate, we are going to let it dry, let us see. And what is the source of energy? It is typically obviously the sun and the moisture content or lack of moisture in the ambient air. So, these are the relevant aspects, let us see, right. So, let me move on. This is a simple aspect. So, we see this, but one aspect to note is that typically you would prefer to have them lined, but in India I see that they are lined if depending upon the type of plant operator and such, right. If not, you can have issues with leaching, especially during the rainy season, and you will have to cover them too to prevent that aspect, I guess, right. So, let us move on. Again, these are the aspects that we already looked at. So, sludge loading rate, kilograms per meter square per this particular time, I guess, right. So, type of drying beds, conventional sand, paved, which is what I was typically mentioning, and artificial media or vacuum assisted, rarely looked at, let us say again. So, typically you are going to go for drying beds because of its simplicity in general, at least in India, and vacuum assisted and such, again you are going to increase the complexity. So, typically in India we do not have that, typically we look at paved drying beds, that is it, right. So, solar paved beds, that is the what we typically look at. So, disposal, now that I am done with it, where is it that I can dispose this dewatered stabilized sludge? So, depending upon the kind of source and the kind of contaminants, as in if it has remarkably high strength, what do we say, ions of different ions, or God forbid of heavy metals, then obviously you can't dump it into the agricultural field, right. So, what is it that we are looking at? The ultimate disposal, it is critical that the ultimate solids disposal or reuse program be a reliable, environmentally sound practice. Why is that? For example, you have, let us say hazardous, not hazardous waste, let us say a common effluent treatment plant where the sludge is coming in from different industries, and concentration of heavy metals might be relatively high, might be, or typically they are. And after primary treatment, you are going to have that sludge, and let us say dewatering that sludge by law is required to go to the hazardous waste storage facility, fine, we are talking about the Indian context. But even after biological treatment, the what do we say, heavy metal concentration in the sludge might be high, and in India typically sludge they use drying beds a lot, quite often. So, after drying, if the relevant CETP operator thinks that okay, he can give this to the farmers, is that a great idea? No, right? And that is why farmers who initially took such kind of sludge burnt their hands and saw that their productivity or such was affected or might have led to other issues, and they stopped taking it. So, again trust is going to be an issue, but more importantly we are looking at disposal which is environmentally sound, let us see, right. Okay, requirement in India, let us see what we have or what is required. At least 7 sewage sludge samples should be collected at the time of use or disposal, and what is it that they are required to be analyzed for fecal coliform during each monitoring period. And then we are going to get the geometric mean of these particular density of these samples and what is it that they should meet. So, we have less than 20 lakh most probable number per gram of total dry solids, or less than 20 lakh colony forming units per gram of total dry solids. In general, depending upon how well you are running it, typically that is going to be achieved, let us say. But again here in India it looks like we are mostly looking at fecal coliform, but as I mentioned earlier, heavy metals are of considerable concern too, and the relevant concentration of cations that you might add to the relevant sludge too. So, methods of disposal, landfill, but this is costly. So, depending upon the kind of sludge, or as in is it industrial waste that was treated, or is the sludge coming from industrial waste and such, landfill, or if it is a general sewage treatment plant, let us say IIT Roorkee sewage treatment plant, only the waste from the kitchens, bathrooms and such, right. So, that sludge after relevant digestion and dewatering or stabilization and dewatering can go for land application, right, for agricultural uses and for other application rates, let us see. For example, Miyawaki forests, if you use this particular sludge, it is going to lead to remarkably accelerated growth of the trees and plants, right, or for soil conditioning for what is this, for gardening and such. So, let us move on. Incineration, but again not a great practice. If you are trying to inject the biosolid into the soil, this is what it will look like in agricultural practice. You are going to have these rows and you are going to inject the biosolids there. So, with that I guess I am at the end of our course, but my TA Bharat wants me to discuss one last aspect which looks like people are asking in exams, some exams, and more importantly in interviews though. Let me just discuss this finally, I guess, right. So, we looked at different kinds of treatment plants, and in that context we primarily looked at activated sludge process and we looked at anaerobic process for sludge. So, at least you are aware of those aspects. But we also mentioned some from time to time industrial waste, and these industrial waste microbes can't degrade, right, either it is too toxic or these aspects, shock loading, microbes are not able to maintain it, and the structure of the relevant industrial waste sometime, at least pharmaceutical waste, is such that they are not amenable to degradation by microbes within a reasonable amount of time. So, what can you do? You can look at advanced oxidation process. Why are we calling that advanced? Because here we are going to look at formation of radicals, right. Radicals are those with unpaired electrons, unpaired unpaired electrons. Let us say OH, this one means it has an unpaired electron, right. So, OH radical, strong oxidizing agent, right. What does it want to do? It wants to take an electron and go to more stable state of OH minus, or it can look at hydrogen abstraction from the relevant compound. So, these radicals are remarkably reactive, like radicals out there among humans, right. So, they are remarkably restless, active, they want to bring about change very fast, right. So, that is good, at least when the society is in different condition. Anyway, let me not digress there. So, we have formation of these radicals, and how is it that we typically do? There are different ways. Let me just summarize the ones that are typically looked at either in interviews or such. So, ozonation. With ozone you are not forming a radical, especially if the pH is low, but if the pH is near about 7, 8 or higher, depending upon the type of reactions, you will almost always have the radical being formed, right. So, O3 or ozone at low pH, just what do we say, ozone, but even then we classify that as AOP because at neutral pH or higher pH it can lead to formation of this highly reactive hydroxyl radicals. And the other one is UV at 254 nanometers and hydrogen peroxide. again that will also lead to formation of hydroxyl radicals. Note that it is not only hydroxyl radical formation, there are other radicals too that will be formed, but primarily we will the chain will start with formation of hydroxyl radical, or the primary species of interest is this hydroxyl radical. There will also be other reactive oxygen species. Another one is titanium dioxide, let us say with the catalyst, right, and you are going to provide the energy so that you move the electron, or the electron can go from the conduction band to the valence band, and then you are going to have an electron and also a hole. So, you can have an oxidizing site and also a reducing site or reducing agent. So, that is one aspect to keep in mind when you have UV-TiO2 or such process, let us see. Now, they are looking at carbon doping and such to bring down the band gap. So, sunlight can also be used. Okay. Some of the advanced oxidation process. Why is this important or why is this relevant? Because these chemical process, first as you can see, at least with respect to ozonation and UV H2O2, what are the byproducts going to be? The byproducts will be H2O, CO2 and oxygen, right. If it is ozone, byproduct is oxygen. So, that is pretty useful and such. So, if we are talking about industrial waste or even canals, where people talk about constructed wetlands, but their efficacy is limited, especially during the monsoon seasons and such. So, you are going to have to look at what do we say, out of the box or consider out of the box options and advanced oxidation process, which are widely used all around the world in developing and also maybe developed, not maybe in developed countries, but which are yet to catch up in India. So, you can use these AOPs for these high strength and difficult to degrade waste. If you do not want to put in a lot of money, what you can do is you can apply these AOPs on waste which are relatively less biodegradable and transform them into more biodegradable waste and have a biological process later. But again, that is a simplistic what do we say information that I just presented, but that is the crux of the issue. And another aspect is when try to sell these, people try to sell these UV H2O2 or ozonation based process, always ask what is the dose, what is the dose of UV that is required, what is the dose of ozone required per liter of water. Why? Because the greater the dose or greater the intensity and the dose and the duration, pardon me, the greater the cost of your particular process. So, one last aspect to note is that after we looked at the relevant costs, as when we just looked at the dose and such, right, one aspect to note is that you will have to be concerned about scavengers. As in, whenever I have the hydroxyl radical, it will either react with my target which I want to happen, or also react with my scavenger which I do not want to happen. But hydroxyl radical, it is not selective, it will react with whatever is out there. So, I have to be concerned with these parallel reactions and such, right. Okay. So, with that I am done with the technical information. So, before I end this session, I need to thank Dr. Batchelor, from whom I learned all the material that I presented in this session or in this course, pardon me, and in the other two courses that I recorded. And also I need to thank Mr. Sharath from our NPTEL office here, who was patiently able to present all this material and edit it and remove the relevant blunders for all the three courses, right. So, with that I will again thank you for your patience, and hopefully you learnt water and wastewater treatment from a different perspective, and I will end this course.